Load balancer algorithms are techniques used in computer networking and server management to distribute incoming network traffic or workload across multiple servers, computers, or resources. The goal of load balancing is to optimize resource utilization, improve response times, and ensure high availability and reliability of services. Here are some common load balancer algorithms. Round robin. In this simple algorithm, incoming requests are distributed sequentially to each server in a rotating manner. It ensures an even distribution of traffic but does not take into account the current server's load or capacity. Leased connections. This algorithm directs incoming traffic to the server with the fewest active connections. It's useful for balancing based on the current load of each server. Least response time. Traffic is directed to the server with the lowest response time or latency. This algorithm requires monitoring and measuring the response times of each server. Weighted round robin. Servers are assigned different weights based on their capacities, and the algorithm distributes traffic accordingly. Servers with higher capacities receive more requests. Weighted leased connections. Similar to weighted round robin, servers are assigned weights based on their capacities. Incoming requests are sent to the server with the fewest active connections, adjusted for the server's weight. IP hash. The algorithm uses a hash of the client's IP address to determine which server should handle the request. This approach ensures that requests from the same client are consistently directed to the same server. Random. Requests are distributed randomly among the available servers. While simple, this method might not provide an even distribution, and it doesn't consider server loads. Chaff. The load balancer generates fake requests, chaff, to distribute with the real requests. This helps obscure the real traffic pattern and improve security. Session persistence. Sticky sessions. This approach ensures that requests from the same client are consistently sent to the same server, maintaining session state. It can be useful for applications that require continuity for a single user session. Dynamic load balancing. This algorithm uses real-time monitoring of server performance and adjusts the distribution of traffic accordingly. It can take into account factors like server load, response times, and resource utilization. Different load balancers or load balancing solutions may use a combination of these algorithms or variations tailored to specific needs. The choice of algorithm depends on factors such as the nature of the application, server capacities, network conditions, and desired performance outcomes.